Alright, so let's review those sample questions. You can go to Blackboard and download the sample questions from week 5, and you have to watch this video in week 4. So let's look at the true-false questions. Question 1. A cost may be direct for one cost object and indirect for another cost object. So we have mentioned this question in class many times. Definitely this is true. The second is a revenue driver is a variable such as volume that causally affects revenue, which is true also. So basically the more products you sell, the more revenues you will generate. So that's basically the idea here. So let's come to the multiple choice questions. So the first one, number 3, which of the following statements about the normal costing is true? Well, this is a kind of a definition question, so if you are familiar with the concepts, then you should be able to solve this question and find the right answer. So the right answer is say, direct costs are traced using an actual rate, and indirect costs are allocated using a budgeted rate. Okay, so I think we just covered chapter 4. So you should be able to find the corresponding definitions in the textbook and the slides, so it should be good. So now let's look at those quantitative questions. Question 4. So this company produces a single product that sells for $100. Variable cost per unit equal $25. The company expects total fixed cost to be $60,000 for the next month at the projected sales level of 1,000 units. In an attempt to improve performance, management is considering a number of alternative actions. Each situation is to be evaluated separately. So what is the effect on operating income with the increase of advertising of expenses by 10,000? So this question needs concepts, needs ideas, needs formulas in chapter 3. So what we're going to do is we're going to use Excel to go through the calculations. Okay. So apparently you might be able to find that the right answer is say, because basically when you increase advertising expenses by 10,000, the operating income definitely will decrease by 10,000 because you lose 10,000. Okay, that's the whole idea. But I'm still going to go through the calculations with you, okay, if you don't get that point. So how to do this question? So basically here is the steps. We can start with the without add. Okay, that's one option, and with add. So without add, what you need to do is, first of all, you need to find the contribution margin per unit. Okay, so we are looking at $100 subtracts 25, which is $75 contribution margin per unit. Then the contribution margin in total is $75 multiplied by 100 products. Sorry, I think it's 1,000 products. So you sell 1,000 units with the contribution margin of $75. So now we can take a look at the OI. Well, before I go there, let me put a fixed cost here. The fixed cost is given 68,000. So the OI is contribution margin total subtracts fixed cost, so which is 15,000. So we're done with the without add situation. Now let's take a look at it with add. So with add, the first two will be the same. Okay, same contribution margin and the same. My computer is kind of slow here. Okay, it's here. So that's what we have. So next, in terms of the fixed cost, you have to be a little bit careful because it's going to be 60,000 plus 10,000 plus 10,000. Okay, if you go back to the slide, basically that's what we have. So therefore, the OI is 75,000 subtracts 60,000, then subtract additional 10,000 advertising costs. So the result is 5,000. So we're looking at 15,000, 5,000. Apparently, if you increase advertising expenses by 10,000, the operating income will decrease by 10,000 from 15,000 to 5,000. So the right answer is C. Now let's take a look at question 5. So answer the following questions using the information below. So we have a beginning finished goods inventory and ending finished goods inventory and balances, CGS, sales revenue, operating expenses. So what is cost of goods manufactured for 2015? So I hope you still remember the flow chart that we have used before. So let me move this Excel file and put them in the same screen here, hopefully. So this is question 3. So what we have here is you should think about how to find the CGS. The CGS will appear in two major calculations. One is WIP. So whenever you manufacture some goods, and once you complete the manufacturing process, then you're going to move those goods finished from the WIP to the finished goods inventory. So therefore, that's one place you can find a CGM. The second one is about sales. Okay, sales. Okay, so these are the two places. These are the two places you can find a CGM. Apparently, we don't have a WIP information, but we do have some sales information. We have CGS, we have ending inventory, beginning inventory, and so on and so forth. So we're going to stick to the sales part, revenues, operations. So first of all, let me put the formula here. So we're looking at the beginning, okay, finished goods. Then normally we add CGM. Then we have goods available for sale. Okay. Sorry, let me make changes. So then together we have the so-called cost of goods available for sale. Oh, sorry, I probably have to do something. Then we can minus so-called CGS. Then to find out the ending inventory of finished goods. I don't know if you see the idea here. So the beginning inventory of finished goods and CGM equal the CGS and ending balance of finished goods inventory. So this is the kind of formula we're looking at. So let me come here. So now I'm going to put all their values. Okay. So for the beginning finished goods inventory, I'm looking at the 92,000. For the CGM, I will put a question mark here because I don't know. For CGS, I'm looking at 300,000. For ending balance of finished goods, I'm looking at 75,000. So if I add a CGM to beginning balance of finished goods, the total amount should be the same as the sum of CGS and ending balance of finished goods. So in other words, if I add 300,000 to 75,000, the result should be the same as I add 92,000 to the CGM. So therefore, CGM is the following. Okay. The CGM basically equals the CGS plus the ending inventory of finished goods, then subtracts the beginning of finished goods. Okay. So for instance, the answer is going to be the result of the following calculations. So it's 283,000. So the answer is B, which is right here. Now let's take a look at question 6. Okay, the question 6 seems to be scary because it's quite long and has a lot of information, but you can use the same idea that I used for you last time. So, for instance, the question, I'm not going to read that table, but basically, what is Leslie's CGS? Okay, similar analysis. If you look at CGS, there are two places you can find a CGS. Number one is income statement. Okay, so basically in income statement you can use revenues minus CGS to find the, we call it gross margin, right? The second place you can find a CGS is we're looking at the sales. So you have beginning and the ending balances of finished goods, and you have CGM and so on. These are the two places you can find a CGS. So now we can go back to the table to figure out, okay, which place we should use to find a CGS. So you have a revenue, and well, you see the revenue, which is good, but you go through that, you don't have like gross margin, so revenue is out of consideration. So now I'm going to look for inventory of finished goods. I have beginning one, I have ending one. Do I have CGM? Oh yes, I do have. So therefore, these are the three things I will need to set up a formula for CGS. Okay, for CGS. So it's kind of similar to the previous question. So I'm going to put a question, I think it's question 6 here. So I'm going to put something here, okay. Yeah, I'm going to put question 6 here. So what's happening here is it's kind of similar. I will have a, so let me just copy paste because we're going to use exactly the same formula here. It's going to be beginning finished goods, then you are going to add to CGM and equals goods available for sale, and you minus CGS, you get an ending balance of finished goods. And also I'm going to put all those numbers into this table here. So here I'm looking at 40,000, okay, and the CGM I'm looking at 114,000. For goods available for sale, I can just add them. Okay, pretty simple calculation. If you do the, if you add those numbers, okay, let me make this. Sorry, I think I'm out. Not here. Let me adjust my window size so that you guys can see the calculation inside of the video. Alright, so here let's add these two amounts. So I'm getting 154,000, and for CGS I'm looking for that, but I do know the result. Ending inventory, okay, of finished goods, I'm looking at 45,000. Okay, so so therefore, if you use CGS to subtract, if you use CGS, you add that to any balance of finished goods, you should come up with this 154,000. So therefore, the CGS is nothing but the goods available for sale minus the any inventory of finished goods. So the result is 109,000. Okay. So the answer therefore is D. It's a D. So now let's take a look at question 7. Okay. Alright, so the question 7 is the one we have, you know, you guys probably watched the video. I didn't get a chance to talk in the classroom, but I made a video for week 3. So this is basically, we're talking about the sales mix questions. So you try to sell 2 products, and they have a sales mix ratio, and each one has different contribution margin. The question is how to find the break-even point. So let's take a look at the question. So we are looking at question 7 this time. So there are 2 products. We're looking at product X, product Y. So I'm going to put X here and a Y there. Okay, let me put put them in try to change a little bit here. Okay, sorry. Alright, so we're looking at X and Y here, and first of all I'm going to find the contribution margin per unit. So for X, I'm looking at 15 minus 2.5. So for Y, I'm looking at 25 minus 10. So we have a $12.5 per unit and $15 per unit for X and Y respectively. So the next one we need to find out is a bundle. Okay, a bundle consists of a number of X and a number of Y units sold. Okay, so if you look at the question, the sales mix consists of 2 units of product X and 1 unit product Y. So we are going to have a bundle of 3 units, 2 units of X and 1 unit of Y. Okay, to have this bundle. So the bundle we are looking at 2X and 1Y. Okay, so we're looking at 3 units in total. So in terms of a bundle contribution margin per bundle, okay, what we can do is we just add the total contribution margin within the bundle. So we have a 2X, so we multiply 12.5 by 2. Then we have a 1Y, which is 15 times 1. Okay, so the contribution margin per bundle is 40. So that's all we have. Okay, so I'm going to put a 40 here instead because I don't want to kind of confuse you guys very much. Okay, I want to move this entire calculation to this place. Okay, so we're looking at the 40. So therefore, the break-even in bundle is going to be the fixed cost divided by the contribution margin per bundle. So let me find out the total fixed cost. It's given 50,000. So I'm going to divide 50,000 by 40 to find break even in bundles. So I get 1,250 bundles. Okay, so we know that each bundle consists of 3 units, 2 of X, 1 of Y. So therefore I can multiply this the number of bundles by 2 to get the number of units of X, and I'm going to multiply the number of bundles by 1 to get the number of units of Y. Okay, so therefore now I can come to the question answers to find the right answer. So we need to sell 2,500 of X units, okay, and 1,250 units of Y to break even. So therefore you can find the answer. The right answer actually is A. Okay, is A. Now let's take a look at question 8, which is the last question in the sample. Okay, so this question is about chapter 4. Okay, so we have learned chapter 4, and we're going to use some of the concepts to find question 8. Okay, so this company manufactures something, okay, using machine hours as a single indirect cost rate to allocate manufacturing overhead costs to the various jobs contracted during the year, and the following estimates are provided for the coming year for the company and for the high school band jacket job. So that's what we have here. You have direct materials, direct labor, manufacturing overhead costs in total, and you have total machine hours, and also you have the machine hours consumed by the high school job. Alright, so what amount of manufacturing overhead cost will be allocated to this job? Okay, so quite a nice question. Okay, so first of all, we have to find out because we're using machine hours, therefore how we need to find the manufacturing overhead cost rate. Okay, cost rate. Basically, we'll try to find out per machine hours. Okay, per machine hours, how much is the manufacturing overhead cost? Okay, so this is a question we're looking at. So in that case, let's do the following. Okay, so we started with question 8. So first we need to find the manufacturing overhead per machine hours. Okay, per machine hour. So we look at the total cost, which is 45,000, then divided by 100,000 machine hours. Okay, I think I probably did too much. So we look at 45 cents per machine hours. So now let's look at allocated, okay, MOH to this high school job. So we look at how many machine hours are consumed in the high school job. We're looking at the 900. Now we multiply 900 by this universal, the company-wide, the manufacturing overhead per machine hour. Okay, you may have several other jobs, okay, consuming those machine hours resources. If that's the case, you can also find allocations to those different jobs. Okay, but the question is only asking us for this particular question. So let's find out. That equals 900 and multiplied by. I should have given me the calculation. Let me redo some of the calculation. It's going to be this one multiplied by 900. Yeah, the answer is 405. So this high school job, okay, we should allocate $405 of manufacturing overhead costs to this particular high school job. So we're using so we should use pick the answer C. So that's the right answer. Alright, so that's about a review of sample questions for chapter for the first exam. I hope you studied the first study for the first exam well, and do the best you can. Thank you very much.